All right, plot the point negative 2, 4. Watch my cursor, if I'm starting here at the origin, how do you think I'm going to get to the point negative 2, 4? So starting in the middle, how do I get there, do you think?
You go left.
How many places?
2.
2 places to the left. I'll make a mark. And then what do I do from there?
You go up 4.
Up 4. 1, 2, 3, 4. You don't have to make these marks, but I do it to indicate how over I am and how high up I am. So there's the point negative 2, 4. A little bit sloppy because I didn't get it right on the corner, but nonetheless, that's the point. All right, try this one. All right, if I ask you to plot the point negative 3, negative 5. Always start at the center, at the origin. Where would I go from there?
You go left 3 times.
Left 3, and then what?
You go down 5.
1, 2, 3, 4, 5, and I'll put a dot in that spot. And so that's the point, negative 3, negative 5. Try that one. Plot the point 4, negative 1.
You go right 4, 1 down.
So we start here at the origin and go to the right 4, 2, 3, 4, and then down 1, and I'll put a dot. Very good. I think most people are pretty familiar with this part of it. How about the point plot the point 3, 0.
You just go over 3.
So starting at the center, you said go over 3 or which way?
Go right 3.
Go right 3. So 1, 2, 3. And then now that I'm there, what now?
You just leave that.
Right. It's that right there. You can put a dot right there. Exactly. That point there then is 3, 0. Let's plot the point 0, 2. So once again, start at the origin. What should I do to get to that point?
And go up 2.
Go up 2. Put a dot. 0, 2. Good. How about the net point negative 2, 0? So I'm starting at the origin.
You just go left 2 times.
Put a dot right there. Let's do 0, negative 4. So starting at the origin, I'll go down 4 units and just put a dot because I won't go over any. And then the last one, just so we went and made sure that I have taken care of all the business that we need to here. Where is that thing?
It's on the origin.
That is the origin, isn't it? Right in the center. Okay. By the way, that there's words for this. This horizontal line is called the x-axis. And this vertical line is called the y-axis. If I can fit it in there. Okay, that's the terminology that we need. Now we're going to start graphing some things in a little more vigorous way, and we're going to be using these ideas. Let me see if there's anything in the book that I need. Nope. Okay, so let's do the following then. So start it off with graphing a line like the following. Now I think I can, if what's in here, oh, I don't want that stuff. Let's see if I can find out where it is. Yeah. Looks like I used the ruler. Okay. Let's bring it down one. So at least for now, try to make some sort of a graph paper. It doesn't have to be that great for this lesson, but oh, by the way, and you can print it off. There are websites that offer graph paper for free as well. Okay. So I have an equation here. Y equals 3x plus 2. Both x and y are variables here. That means they can take any kind of value you can imagine. What I do is I try to make a little chart, and I pick some values for x, and I'm going to graph them. I'll show you what I mean. If I allow x to equal 0, then y will equal 3 times 0 plus 2. That equals 2. All right, the point that we get from it, we get 0, 2. That's because x is 0 and y is 2. So to graph this thing, I'll start at the origin, and to get to 0, 2, I will simply go up 2 places, and I'll put a dot. Now I need to pick a different value for x. I really don't care what you pick, but I think it's probably easiest to pick the value of x equal to 1. Keep it as easy as possible. So then I'm replacing x with the number 1, so y is 3 times 1 plus 2, which is 5. So that tells me that I have a point at 1, 5. So starting at the origin, I will go to the right 1, and then I will go up 1, 2, 3, 4, 5. And I'll put a dot up there. Now I can connect these 2 points with my ruler, and that would be what is expected of me here. However, I would like to know if I'm doing it correctly, so I would like to do something to check my work. So I'm going to pick another number for x, say -1. Now, when I replace x with -1, y is also going to equal -1. and we have the point -1, comma, -1. So I will start at the origin again. To get to -1, -1, I go to the left one, that's x equals -1, and then down 1, that's y equals -1, and I'll put a dot. Now, I can tell if I've done it correctly if my 3 dots line up. Would you say that the dots are lining up here?
Yes.
It's hard for me to do it, to hold it here because it's so. It's about as close as I'm going to get it. And I get the line. So the game plan here is you're given an equation. You pick some values for x. You pick them, plug them in, see what you get, graph them, see if they've lined up. So let me give you one just like it. Even though you may or may not have graph paper, try the next one on your own. Try that one. Take a few minutes to do that. I'll do it when you're done. I'll do it just to make sure everybody's on the same page. Okay, when you guys did it, did you get them to line up? We still have 4 people. I don't see.
I have forgot how to do it.
All right. Remember, when x is equal to 0, you're going to replace. I made a mistake, didn't I? Yes, I did. Erase that. That plus 30. So you replace x equal to 0, and you end up with y equals 3. So the point is 0, 3, which is just up 3 units. It's on the y-axis. When we replace x equal to 1, we plug that in. You'll notice in this case y is equal to -1. And so I have to plot the point 1, -1. To do that, I'll start at the center, go to the right 1, and let me see, where's it? 1, -1? The right 1 and down 1. Now, if everything's correct, I can graph a line and it will go and connect those 2 points and everything's fine. Although I would like a third point to tell me if I'm doing this right, because they should all line up. So let me plug that one in. This time the -4 times the -1 is +4. 4 plus 3 is 7. And now to plot that, I'm going to start at the origin and go to the left to x equals -1, and then go up 7 places. 1, 2, 3, 4, 5, 6, 7. I know it's off my graph, but I'll put the dot up here. And they look like they line up. The only way to know for sure is to take my ruler and lay them out to see if they do line up. So let's see if they actually do line up then. This ruler is a bit weird. I can do it better on paper than this thing. Yeah. Let's see here. See if I can keep that one locked. No, it keeps moving on me. Oh well, okay. I don't know. What do you guys think? Is it lined up? This can be impossible to graph. Well, I don't know what else to do, but it looks like it lines up to me. All right, connect them with a straight line if your ruler will let you do it. Terrible. That's horrible. Let me do it. Okay. That's about as close as I'm going to get. Not too bad. Let's try again. Try again. What happened to you? That.
They look lined up on my graph.
They line up?
I use 0, 2, and 4.
It shouldn't matter. It wouldn't matter. For my case, when I plug in x equals 0, I get 0. Sorry, that was a mistake. It actually equals -1. When x was equal to 1, I got -4. And then when x was equal to -1, I got 2. So check those values out if you use those, see if you got the same thing. So if they lined up, you should be good. Let me check a few things here, and we can tell for sure. 0, -1, I simply move to the left one place and put a dot. The next one I have 1, -4. So I go to the right one and I go down 4 units.
Oh, you said 0, -1?
That's what I have. You may not have that. You might, like, you use different numbers than I did.
I'm saying for your y-axis, don't you go down?
Oh, yeah. Good job. Yeah, you're right. Let me take it out. 0, -1. Yes, you go down 1 unit. Got that? All right, the 1, -4 is what I'm working on next. So I'll go to the right one and then down 4 units and put a dot. Then I have -1, 2, so I'll go to the left 1 unit and then up 2 units. Okay, so mine line up. You said yours do too. We can tell if we got the exact same thing by looking at where it crosses the y-axis. So looking at your points, if you put your ruler right up there or you try to use some sort of way of estimating, is your line going through the point 0, -1?
Is it going through it?
Yeah, let me draw. Oops, I don't know what I did. Wonder why it's doing that. That's way off. This side doesn't work as well. This side doesn't work as well either. Oh, that's funny. Let's see how far over I have to move for it to work out. Pretty close. It's as close as it's going to let me go today. All right. All right, let's mix it up a little bit with a little more complication then. What do I want to put? Try that one.
What happened when you get a fraction?
It's tough to graph those.
All right, so just like do
You
another
can,
number.
yeah, try another number. You can avoid it if you try. Now remember, you're allowed to use any numbers you want. You're absolutely not restricted in any way. I don't think I'll need that much, but whatever. What I do is I allow x to equal 0, and then I allow y to equal 0. So when x is equal to 0, this equation up here, when x is equal to 0, this equation becomes negative 3y equals 12. And so y is equal to negative 4. And then when y is 0, I get 2x equals 12. And then the hard part would have been graphing more than 1 point after, or more than 2 points after that. So like if you'd have tried x equals 1 or something like that, you probably would have run into fractions. But instead, what I'm going to do here is this. So I subtracted 2x from each side, and then I'm going to divide by -3. Let me circle that one too, because that's the same equation, but it's just been manipulated a little bit. Now, you said you ran into fractions. That's because if you try to replace x with some number that 3 doesn't go into, then you're going to get a fraction. Give me a number that 3 would divide evenly into for x.
9.
9. When you replace x equals 9, you're going to have y will be 2/3 of 9. So I replaced x with 9. 9 over 1 just to make it useful. This way, this avoids the fraction. This canceled out the fraction. 2 times 3 is 6. But then when I subtract 4, I'll just have 2. So let me put my numbers in. My 0, -4. So I just go down 4 units. Put a dot. 6, 0 gets another dot. So starting at the origin, I just go to the right until I get 6 units. And this 9, 2, I want to check it out to see if it lines up with these 2 points. I hope I have enough room for this. So starting at the origin, I'll go over to the right 9 places, 7, 8, 9. So I got there, put my thing 9. Now I'll go up 2. Now look at these 3 points. Do they look like they line up?
A little bit.
Let's use our ruler, even though it's proven to be a pain in the butt to me. Let's see if I can get it to line these up. I don't know. What do you think?
Yeah.
Let me see if I can get it. Oh, good. They actually lined up very nicely there. I don't know how much space I need. Figures. At the ends of these lines, we put these little arrows. Do you know why we do that?
To represent another two numbers can, you know what I'm saying?
There will be more solutions. It means that it goes on forever in both directions. That's all the arrows mean. A line never. A line has no length. It just goes on forever and ever. So what we've done here is just a little intro to graphing. We're going to do a little more deeper graphing when you come back. Take 10-minute break, and then we'll come back and do some heavier graphing. 1-0. All right. Okay. I'll just leave it at that graphic, I think. All right, we'll go ahead and start with this line for the second half. Let me get my graph in place. Now, for a problem like this, it's always easiest to allow x to equal 0 first. Because when x is equal to 0, this part here, this 5/3 x, all becomes 0, and all you're left with is 3 for y. Let me graph that point. So when x is 0, y is equal to 3. We call that point the y-intercept. That's the place where it strikes the y-axis. Now, by looking at this equation up here, and notice when you're graphing things, you can only graph things if they hit a nice corner, or what do you call it, where two lines on the graph intersect each other, like where my thing is at these corner points. That's the only place where the points should be if you want them to graph. If halfway or a quarter way or whatever, some fractional amount, won't do any good on a graph. So knowing that fractions don't work well on graphs, can you give me a number that you might try for x that would make this fraction free?
3.
If you try x equals 3, what do you get for y?
-2.
That's right.
I do.
3, -2. So I'll graph that. I will go, starting at the origin, I will go to the right 1, 2, 3, and then down 2. And so there's my 3, -2. Now we have 2 points, which is enough to graph the line. However, if I want to be certain that I am correct, I would like to graph another point. One more, and that would tell me that I'm absolutely positively correct. So 6, yes, 6, 3 goes into 6 very well. Perfect choice. You could have done -3 also.
Oh yeah.
You could do 9, 12, whatever. It really doesn't matter. But since we want to keep it small, since we're going to actually physically graph this stuff. So when x is equal to 6, I get y is equal to -7. Is that what you get? If I need, I'll do it over here. 5/3. That's negative 5/3. You make it 6/1. Negative 10 plus 3 is, yeah, negative 7. So start at the origin. I will go to the right 6 units. 3, 4, 5, 6. And then I will go down 7 units. 1, 2, 3, 4, 5, 6, 7. All the way down here is my third point. If they line up, I am good. So let's check it out. I think that's lined up. We'll see how close it is. A little bit off. There we go. And they look like they line up. Let me push it over just a smidgen. Or maybe move my graph back a little bit. So my line will fit in there. Hey, what's wrong with you? Stop touching things. All right, it's not going to do that. Then I'll see if I can do this. Okay. All right. While I am here, this place right here, what do you think they call that point where it crosses the x-axis? Give you one guess.
Intercept.
You have the X-Intercept. All right. So while we're here, check this one out. If you can let X be 0 and see what you get for Y, and then allow Y to equal 0, and then see what you get for X. In a case like this, it works out well for when X equals 0, Y is equal to 2. And when Y equals 0, X equals negative 10. Let me fix that. So 0, 2, when I go to graph that, I'll go up 2 units from the origin. And then negative 10, 0. I'll go to the left 10 places if I have enough room. 1, 2, 3, 4, 5, 6, 7. Uh-oh. Can you get over there? It won't stay over there. So let's do this. Since it's so far over, I'm going to give myself space. Now let's try this again. 0, 2. I'll go ahead and put a dot up here. There's 0, 2. Negative 10, 0. Let's see if I have enough space over here now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's right on there, right on the edge. So let me get it in there. Okay, so I've got that point over all the way over there. I've got this point. I need one more. I guess what I'd probably do, since if I plug in a number for y, I don't have to divide anything except for -1 in front of x, so I can probably put about anything I want in for y and get a good value for x. So pick anything really.
I'll use 5
For what? For what? Y?
for X.
5 for x. And what did you get for y?
3.
That is correct. I'll use your number.
I use 1, and I was gonna get a fraction.
Yeah, you use 1. Yeah, so you've got it. Different equations are going to require different things. If you try graphing a fraction is just not going to happen. Unless it's a half. A half is not so bad, but anything besides that, I don't trust. So this 5, 3 that you got. So I'll go to the right 5, 2, 3, 4, 5, and then I'll go up 3, 1, 2, 3. Let me put a dot. And let's take a look at these points. Oh, I know it.
It look off to me.
They are. Let me move up a little bit here. They are. It's just my drawing is a little bit. Oh, you know what? Do you see my middle point is a little bit below?
I'm sorry. You don't have to get smart and have something to say every time I say something.
I do believe they line up, though. Just it's the way I graphed it didn't work out so well. But you can see my line does go through the corner points. So what this is this guy right over here, the 0, 2. That was the y-intercept. And then we had the x-intercept. So this is an example where we were able to graph something by using the intercepts. Let me give you one to try. So if you can, make use of the intercepts to help you graph this thing. Let's try. Go ahead and try that one. Here you shouldn't run into any fractions no matter what you pick. Let me move it around like this. Or not. In this particular one, you should have been able to graph using the intercepts. You should have been able to plug in x equals 0. And I think when you plug in x equals 0, you get y is equal to 3.
Yeah.
And then when y is equal to 0, x is equal to 3. Yeah, I believe so. Okay, so let me put those points in. This one here is 0, 3, and then this one here is 3, 0. And then give me one other point just to check. This is my proposed line right now, just through these 2 points. Let me have one more as a check. I don't really care. I probably do.
I use -4. I mean, negative x equals -1.
X equals, so you got x equals -1, and then y was 4.
Yeah.
All right, so let's see. Oh, that 4 looks well. Let me fix that thing.
And my dots are aligned.
-1, 4. Well, let me check and see here. Starting at the origin, I go to the left 1, and then I go up 4 units. Yours don't line up?
Mine do.
Okay. I was going to say, it won't let me draw the point because it's too close to it, but my third point was right here. All right, good. So you can see in different situations, you have to do different things to graph them. Here, I'm going to give you a weird one then. Let me give you, there's a couple more types that I want to graph, and will be good. So let me give you, try that one. get over there. Move over. Move like that. Good. Oh, really? I had no idea it would do that.
So I use X equals 0 and I got 0 for Y.
That's right. So that just goes here. You need more than that though to graph a line, so you probably had to pick some other stuff. If you pick, unfortunately, that means that I've already taken care of y equals 0, so it looks like I need to come up with 2 other points to make this work.
I use X is -5 and I got -6.
You said x was -5.
Yeah.
X was -5. So we have it. I think. Let's see what happens there. So if x is -5, let's do it down here. We're going to get 6 times -5 minus 5y equals 0. -30. All right, so yes, I believe you do get y equals -6. Let me put that on there then. So I'll go to the left 5, 1, 2, 3, 4, 5, and then down 6, 1, 2, 3, 4, 5, 6. Got my dot. Any other places any other numbers you suggest?
5 X equal +5.
All right, x equals +5. That'll probably work too. So I have 6 times 5 minus 5y will equal 0. Oh yeah, I can tell that y is going to equal 6 then. So if x is 5, y is +6. Now let me put that in then. Go to the right 5, 2, 3, 4, 5, and then up 6. 1, 2, 3, 4, 5, 6. So they do look like they line up. So let's see here. Oh, yeah, that's right. I forgot. Let me get it a little better. Okay, that might work. My original's a little bit off, but I think the line, actually, you know what? My y-axis was off. All right, so there you have that situation there. We had 0, 0, only gave you 1 point. So what I want to take care of is the strange situations now. So that was taken care of. Another strange situation looks like this. You notice you don't even see an x value, an x there.
So you'll still solve for y though? I mean,
Yeah,
you'll
so
still plug in for y.
still do the same things you did before. Yeah, plug in or for x or whatever. Like, but there is no x. I'll show you there technically can be if you want, but it's not listed there. So you may got left. Anybody get a graph of this thing yet?
I couldn't.
All right. Well, if you allowed x to equal 0, what did you get for y?
-3.
Okay. Now, what you can do with this equation,
Hold on, you could just add a x into any equation.
like this. See what I did?
Yeah.
Now you have a place to put the x values in. Even though they won't mean anything, like if I put in x equals 1, can you tell me what the y value will be?
I gotta work it out.
There's not a lot to work out. If you replace x with 1, what's 0
Oh, it'd
times
be
1?
-4.
No. What's 0 times 1?
Oh, 0.
So 0 plus y equals -3. So what does y equal?
-3.
That's right. You can see no matter what, I could put in 1,000 or let's put in 2. If I plug in x equal 2, what are you going to get for y?
-3.
That's right. Getting the idea now?
Yeah.
No matter what you plug in for x, y is always going to be -3. So let me put a point at 0, -3, and then everything. We had 1, -3. We had 2, -3. I had -1, -3. Do you see what it's going to be here?
Yeah.
That's going to be a horizontal line. Come on down. Here we go. I think that'll do it. There's our line. And it goes through where y is -3 on the y-axis. So this is a horizontal line. Okay. Now there's no y involved. What kind of a line do you think is going to happen this time?
It's gonna be a vertical line.
That's right. In fact, once you recognize that these are specialized lines, you won't even have to bother drawing points or anything, because all I got to do is locate 4 on the x-axis. So starting at the origin, I'll go to the right 1, 2, 3, 4. So if I marked that number, that would be a 4. And then my line is vertical. So these are special lines. When you see y equals b or x equals a, that thing is horizontal. That thing is vertical. Okay. Try that one. I think always it's not a bad idea just to try throwing in x and y equals 0 just to see what happens. If you get a fraction, then move on to something else. While you're doing that, I think while you're doing that, I am going to assign homework. Well, what are you doing? Oh, I see. It's as far as it goes. Okay. Let's see. Today's date is the 10th. So this will be due on the 16th. And there we got homework for 4.1 and 4.2. Now let's go back here. Okay, how's this? Anybody get this graph yet?
Yeah, I got I ain't use zeros.
Okay, what'd you use?
I use -1
For who?
for X.
All right, so a -1 for X. What'd you get then for Y?
I got 2.
I don't know about that. Let me see here. For X equals -1, that means it would have -1 plus 3Y would equal -5. All right. Then you add 1 to
Oh
both
no, no,
sides,
no,
right?
no, no.
You know what you wanted to use? Use
I
positive
forgot that's a
1.
-5.
Right. Use positive 1 instead.
Okay. Well, that's the case. Hold up. I use -4. And got -3.
It ain't gonna work. Don't the negative numbers. Remember, when you add them to the other side, they changes to an addition. I think you're thinking backwards.
Okay, then use 4.
4 for which one? For X.
Yeah, not -4.
All right, we'll use 4, and then I'll get 3Y equals -9. All right, that'll work. So 4, -3. All right, let me go ahead and put that in. X equals 4. I'll go to the right. 1, 2, 3, 4. And then I will go down 1, 2, 3 and put my dot. Okay. Did you get any other points?
I use 7.
For which one, X or Y?
X.
Okay, so when X is 7, let's see what we have here. I get 7 plus 3Y equals -5. Yeah, this is going to work too. So 3Y equals -12. So 7, -4. So let me go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay. That'll work. I can graph that and get a line. But if I wanted to be absolute certain that I got the correct thing, what could I do next?
Find an additional one.
One more. This is where you could do Y. Look. If Y was equal to 0, wouldn't this 3Y disappear?
Yeah.
If Y was equal to 0, if that 3Y disappeared, what would X equal?
-5.
So that's a good point. That'll work. Let me throw it on. 0. And then go down. Or I'm sorry, I'm going the wrong way. -5, 0. I have to start at the origin and go to the left. 1, 2, 3, 4, 5. And I'll put a dot. If you try to let X equal 0, unfortunately, you're going to get a fraction for the Y-intercept. So I wouldn't want this one. Well, let's see if they lined up. Did you have a third point on your own that you tried?
No. Nope.
What do you think? Think they line up? What do you think? Line up? They look like it.
Yeah, it look like it.
little errors at the end. And so you've seen the various ways that we have to go through to get these graphs. What we're going to do from here on out is in the next class and the classes after that, we're not going to concentrate so much on graphing points and connecting them. We're going to start doing things with the equations themselves. And from the equations themselves, we'll be able to get some graphs. But that won't be till next time. So I've assigned homework 4.1 and 4.2. It's due in 6 days, which I guess would be Tuesday.
Can we still meet in class next week, or?
If you'd like to. Did you show up today?
No.
Because I didn't go down. I didn't see anybody down there, so I didn't even bother going into the classroom. I honestly don't care. I get more exercise in the classroom than I do in my office, so we can meet wherever. If nobody shows up, I'll just go from my office. If you
Okay.
show up, I'll do it in the classroom. So it really doesn't matter to me.
Okay, that's cool.
All right. And think about your tests. Please look at them and have some questions about them, because even though you'll get a chance to do better on it when you take the final, I think you'd like to know how to do the problems you missed. All right. I think that's all for today. If there's no questions, I'll go ahead and be done. Okay.
You have a good day.
You too. All right, let's go ahead and stop the recorder.